Okay, so we are going to look into a couple of examples using logistic regressions. So far, we've seen how these models are implemented within our packages or within, packages in any other languages. We've explained how logistic regressions are very similar. The way they are trained, the models are very similar to linear regressions. The only difference is that the predicted values are squashed between 0 and 1, and so basically these values between 0 and 1 are used to represent probabilities. And then the probability, say in a binary classification, if the probability of one event is higher than the other event, then we will assign label 1 or 0, okay? So right now we're going to cover a couple of examples on using packages in R. The first example is going to be a very straightforward example where we will just train and test a logistic regression. For a binary classification problem, we'll just use or learn about the package in R that allows us to, one of the packages in R that allows us to do logistic regression. We will train a model, test it, and see the output and how to identify how good that model is. And then the second example will delve a little bit more into the model itself, looking at the weights that have been learned and what those weights are telling us about the importance of the different features, and basically looking at how the probabilities of different classes being assigned changes with respect to the input. Okay, so let's start with the first example. For the first example, we're going to be working with a data set that's called social network ads. And basically this data set has information about gender, age, salary, and a binary variable that we call purchase. Purchase is a yes or a no, a 1 or a 0, and basically what this data set is telling us is, given these characteristics of an individual in terms of gender, age, and salary, did they buy a product or not? The question that we're trying to answer here, or what the predictive model that we will build is trying to do, is given these characteristics, gender, age, and salary that are independent variables, can we predict whether someone will purchase a given product or not? Okay, and that's a logistic regression because basically we're just predicting two classes, purchase yes or no, purchase 1 or 0. The data set we'll be using, as I said, it's social network ads, and so let me show how this could work in R. Let me open this. Okay, perfect. So the first thing that we do is load the data set. Okay, just make sure I've already set up my working directory. Make sure that your working directory is set to wherever you have saved this file. The first thing that we need to do is to load the CSV file. Okay, it's a CSV file, so we use the read CSV command, and now we can check what we have read. And as I was saying before, this is, the data set that we were talking about. Okay, and basically we have the gender, the age, the salary, and then purchase 0 means there was no purchase, purchase 1 means there was a purchase. Okay, this is the data set we're going to work with, and we want to build a logistic regression that will tell us this 1 or 0 based on these 3 independent features. Okay, so how do we do this? So we're going to be using the first thing that we'll do, like in any training approach, the first thing that we need to do is split our data set in training and testing, right? Typically we use between 70 and 80% of the data set to train the model, and then the remaining 20 to 30% of the data set to test the model. Okay, and so there is many different ways of splitting a data set into training and testing. Last week we saw one. This week we're going to be using this sample split, and what sample split does is, again, it basically generates, in this case it generates true false variables, and 75% of them will be true, 25% of them will be false, and then we'll use those true false variables to create a training and a testing data set. So let's see how this works. Okay, so in order to be able to use sample split, we need to load a library which is called CA tools. Okay. Then to make sure that the distribution of these labels is random, we just randomly pick one seed. And then what we do is that we use this sample split command, okay? So we take the data set, and then we set up the command to basically what this is a sample split command is going to do. If you take a look at this, what it's basically doing, it's saying, okay, basically take, you know, the 400 values that we have in our data set, the 400 rows, and then for each row we are going to randomly assign a true or a false value to each row in the data set. Okay. This is assigned randomly based on a random seed that we have set up with the set seed command. Okay, and now basically what we can do is say, okay, so all of these rows in the data set that have the value to true are going to be part of the training data set, and all of those that have this value set to false are going to be part of the testing data set, right? And that's exactly what we say. So we create a training set. Okay, and the training set, what using again part of this sample split command or the split commands, we say, okay, create a subset using dataset as the original dataset, and take only those rows whose split value is true. Okay, this is going to be our training dataset. If you take a look at the training dataset, as you can see here, let's look into that. So for example, the true-false labels that we generated, for row number 1, it's true, okay? For row number 2 is false, for row number 3 is true, and so on. These are the labels that we have generated, okay? And so basically what this means is that row 1 will be part of the training data set. Row 3 will be part of the training data set. Row 6 will be part of the training dataset, and so on. And as you can see here, rows 1, 3, and 6 are part of the training dataset. Okay, so again, this is just generating as many true-false labels as rows we have in our dataset, and then the subset command is basically saying, okay, so any row that has a true value here, we're going to take that row as part of our training dataset. And we do exactly the same thing with the test set. So we create a test set, and in this case we would say, okay, so just the test set is going to be a subset from the larger data set that we have, but in this case we're going to take the rows where the split value that we have created is false. Okay, and so if we take a look at the test set, in this case we have these values, so let's look at that. So for example, the second row had false, the fourth row had false, so you know those that have false values are the rows that are going to go into the testing data set, in this case 2, 4, and 5, and you can see here rows 2, 4, and 5 that are part of the testing data set. Okay, so now that we have our testing and our training and our testing data set divided into 75% and 25% of the samples, we are ready to build the classifier. So to build a classifier, we're going to use one of the several commands that can be used for logistic regression in R. In this case, we're going to be using the GLM command, okay? And the way the GLM command works is that you need to determine, or you need to specify first, what is it that you want to predict. In our case, we want to predict the purchase column, okay? Purchased column, which is this one here. And then you have to specify what variables you want to use to predict it. If you want to use all of the independent variables that you have here, then you can just put a dot. Okay? Okay. Then we have to determine the family that we use, which could be the binomial family. And then you have to specify what's the data that you use to train the model. And in our case, it's going to be this training data set that we have created. Now, this classifier, if you sort of write classifier, the name of the classifier, it will give you details about the weights that has learned, and so on. I'm not going to go into describing this because this is exactly what we will be covering in our second example, okay? But just, you know, beware that, as we've been explaining earlier, these models, you can use them as black boxes, but it's important to understand what's going, you know, underneath during the training, that you're learning weights, that the values are being squashed between 0 and 1, and so on, right? And so we'll be talking about these things in our second example. And so now remember that the objective here is to create a classifier that will determine whether someone purchased a product or not based on these different independent variables, right? We have built that classifier. Now we need to see how good our classifier is, right? And so in order to predict, like, given gender, age, salary, in order to predict basically the whether somebody will purchase or not, there's a command called predict, okay? But the command predict in a logistic regression is going to tell you the probability, okay, that somebody will buy something or not. And then we can use that probability to determine whether we're going to assign class 1 or class 0 to that value. Let's see how. So we're going to say, okay, let's output the predicted probabilities. I'm going to call it prop pred. And for that, I'm going to use the predict command. How does the predict command work? You need to specify the classifier that you want to use to predict. We're going to use type response, saying, okay, output the probabilities of that prediction. And the data that we use for the testing is the testing data set that we've created. Okay? If we take a look at prop pred, these are basically 100 different values, only 100, okay? And as you can see here, these are values between 0 and 1. These are the probabilities that the product will be purchased or not. Now, this is a binary classification that we're looking into, right? In the end, we want to know, okay, is this a 1 or a 0? Now, how do we compute that? So we have to come to an agreement, and we can, for example, say, okay, if the probability is larger than 0.5, we'll say that the product was purchased. And if the probability is smaller than 0.5, we'll say that the product was not purchased. We'll assign a 0. And so in order to do that, I'm going to create a new variable, ypred, okay? And I'm going to run the following command, an if-else command. What an if-else command is going to do, I'm going to say, okay, if the predicted probability is larger than 0.5, then assign a 1 label, the person purchased the product. Else, if the predicted probability is smaller than 0.1, then say that the product was not purchased, assign the 0 label. Okay, so this is the way we transformed the probabilities from the logistic regression function, the exponential, the long exponential expression with the weights. This is how we transform those probabilities into a 0-1 label. So if you look at ypred, okay, ypred is just a set of, for the 100 variables in our testing data set, is just a bunch of zeros or ones. For example, if you take a look at the last value, it's 0.52, so 52.1%, and that would be purchased because the value is larger than 0.5. Now, okay, we have these predictions. How do we know how good or how bad our model is? So in order to do that, we're going to use something that we will use very frequently in this course. It's called a confusion matrix, okay? There's a specific command to compute confusion matrices, and I'm going to walk you through that command. You need to load the library gmodels first, and so let's see how we compute that. So let's load the library gmodels, okay? And then I'm going to just cut and paste this command because it's kind of long and I don't want to make a mistake, but basically, let's go back here. So what this command means, this command, we use it to basically compute a confusion matrix, okay? What's a confusion matrix? A confusion matrix is a way of understanding how many times did your model predict something correctly or incorrectly, okay? And this is used whenever we have a classification problem, whenever we have 2 or more classes that we are trying to classify into. We don't use confusion matrices for regressions. For regression, remember, for things like linear regressions, for example, remember that we are predicting continuous numbers, and so we can use, for example, root mean square errors or correlation values, okay? But when we have classes, we use, or we can use confusion matrices. And so let's look exactly into this example, and let's see what we get as output here. Let me make this smaller and this larger. Okay, so this is what we're getting. This is what we call a confusion matrix. Now, what's a confusion matrix? So in a confusion matrix, you have a column here with the predicted values, zeros and ones, and this row here with the actual values, zeros and ones. Okay, this is the output that we get. Maybe let me go to the slide, which is going to be easier to explain. Okay. And so what you can see here, the numbers might differ depending on the package that you run, but it should be very similar. And so what you can see here, the main place that I want you to look into is this square here. Okay, what this square is telling us is that when we predicted when we predicted that the product was going to be purchased, and the actual value was 1 in our testing data set, this happened 78.8% of the times. So 78.8% of the times we correctly predicted a purchase. Okay? Okay. We predicted a 0 value, we predicted a non-purchase. And that prediction was the same as the actual value in the testing data set. That happened 85.1% of the times, meaning that 85% of the times, approximately, we correctly predicted products not being purchased. Okay, this is a pretty good classifier. Okay, we are predicting purchases and non-purchases with really high percentages of correctness. Okay, everything else, or the other values, are, you know, predictions that were wrong. We predicted that it would not be purchased, but it actually was 21% of the times. We predicted that it would be purchased, but it actually was not, and that was 14% of the times. Okay, but these values are pretty good for such a simple classifier. Okay, and now we're going to look into the next sample where we will sort of open the black box of a logistic regression model and understand a little bit better how it works, weights, significance of the variables, etc.